Okay, so you take the thingies of this and you put them right here. And because -1's a 0, you put it right here. And then you carry down the first one, then multiply it, and then add, and then multiply and add, and multiply and add. And then once you get those numbers, you plug it in right here. And then you put that into the quadratic formula, which is the opposite of b plus or minus square root of b squared minus 4ac all divided by 2a. And then if you solve that down, that equals -2 plus or minus root 20 over 2. And then if you, that has a root of 4 and 5, which the 4 can turn into a 2, so then it's -2 plus or minus 2 root 5, and then all divided by 2 equals -1 plus or minus root 5. And that's how you get this, which equals.
All right, thank you. A round of applause to our volunteer. Good job. Okay. Oh yeah, now, okay. Again, you have to practice how to use quadratic formula, okay? Because not all polynomials are factorable, okay? So make sure you know how to plug in those values, the A, B, and C. All right. And any other questions on this? Okay. Again, if you're given one of the zeros, use that and induce synthetic division so that we can reduce the given polynomial. So let's say if it's cubic, it can be reduced to quadratic. And again, from quadratic, you can factor if it's factorable, but if it's not, then use this. Okay? So the answer is this. Any question? So again, today we're going to be doing applications of polynomials, right? It's going to be every time we end the unit, we always end it with applications because that's the goal of the lesson, right? Concepts, to apply that to real life situations or to any situations where these functions are applicable, right? Okay. Okay, and again, on Monday, we're going to have our review day. And then Tuesday will be our test. And again, that's going to be the last test that I'm going to put in for your first quarter, right? So, and again, that's also be the last day to turn in missing work for the entire quarter. Although some of those work will be counted as late, but again, at least it's not a 0. So I will accept until Tuesday, and then the lesson for Wednesday and Thursday will be going to the second quarter, okay? Okay. Any questions? If you have classwork or homework that you want to turn in, you have to turn it now because I'm not going to accept that or it's going to be counted as late after the lesson.
I didn't realize that you have no warm-up one day, so you can have it side to side on your page, and I didn't waste space.
Okay.
Instead of going back to this one, I went to this one.
Okay. Now, since on the EOC, because these are some of the release questions in the end of course test, which is 20% of your final grade, okay? So we're going to practice some application problems that are similar to the release questions so that you can practice and prepare for the test, okay? So, because the goal here is really to help you get that level 5, okay? 99 or 98 to 100% of the score, you get the level 5, okay? All right. Now, so I want anyone to read the problem so we can understand the problem. And okay, Ivy.
The dimensions of a rectangular box are such that the length is 3.25 inches more than twice the width. The height is 2/3 of the width. The volume of the box is 37.5 feet squared. Cubed. What is the width to the nearest tenth of a foot of the box?
Okay, nearest tenth of a foot, so 1 decimal place. Okay, now, so we're given a rectangular box and we're given the volume of the box, and we know, right, remember the formula for volume of a rectangular prism or volume of a rectangular box. We just have to multiply the 3 dimensions, right, of the box. The length times the width times the height, okay?
Oh wait, oh sorry, I was looking at the wrong sheet.
Yes. Okay, so the classwork is actually similar to what we have in the notes, but yes, you're looking at the wrong paper. Okay. All right, so we have, so volume equals length times width times the height. So we need to identify, we need to express the dimensions, the three dimensions, length, width, and height, so that we can use that and plug it into the equation, right? Okay, so if we know that the length of the rectangular box is 3.25 inches, more than twice the width, can you still remember how to set this up? Or how to write this as a mathematical sense? So how do we express the length? 3.25 inches more than twice the width. If you, so let's just express, we can express the width as W, but let's just express the width as X. So if we express the width as X, that's a known dimension, right? So how do we express the length in terms of the width? That's going to be twice the width, so 2x, more than, of course, that's addition. So plus 3.25. Right, in inches. But then, since the given volume of the box is in cubic feet, so therefore we're going to express this in feet. Okay? So because it's given as 3.25 inches, we just have to express this value in feet or in foot. Right? So how do we express this? 3.25 inches to foot or feet. What is or how long is 1 foot in inches? 12 inches. So if we're going to express this by foot, we just have to divide this by 12. Right? Okay. So that's going to be, let's say, what's 3.25 divided by 12? If it's feet to inches, we multiply it by 12, right? But it's inches to foot or feet. So we divide the number by 12. Let's just do 3. What is that? 0. What's the next one? Okay, so let's just use 0.271. Okay, so I can express the length as, just gonna write it here. Length is 2x plus 0.271. Okay, again, we convert the unit inches to feet because the given volume is in terms of feet, right? But if the units are the same, we don't have to convert the values. Okay, so just make sure the units are the same. If it's not, you have to convert. Okay, all right, so that's the length, and we know we express the width as x, right? And then the height, what is the height? That's 2/3 of the width, so 2/3 x. Okay, so this is the length, this is the width, and this is the height, the representation of the height. So we can use all of these expressions, plug it into the formula, and then solve, right? Okay, we know the volume is 37.5, so 37.5 equals, then just copy all the factors, right? So length is 2x plus 0.271, and then the width is x, and then the height is 2/3 x.
Wait, how did you get 2.71 again?
We converted the inches, the 3.25 inches, to foot because you should have the same unit, right? Since the volume is in terms of feet, we're going to express 1 in terms of feet. Okay, but if this is cubic inches, we don't have to convert. So we have to keep the 3.25. Okay, and then, so from here, we just have to simplify this, right? And once we have the equation in standard form, then we can factor. If it's not factorable, again, we can use the graph, okay? You can use Desmos.com for this part, but make sure you set up the correct equation. That's the goal, right? You set up the correct equation in standard form. Okay. So I hope you got this part, and let me just write this here. So what is, if you multiply this, right? You can multiply 2/3 times x, 2/3 x times x, which is 2/3 x squared. So I can write this as 37.5 equals 2x plus 0.271. and then times 2/3 x squared, and then we just have to distribute the 2/3 x squared to this binomial. And so we got 37.5 equals 2/3 times 2. I can write this as 4/3, right? X to the power of 3, right? X times x squared. And then I can just multiply 2 times, you can multiply 2/3 to the entire 0.271, or you can just multiply 2 times 0.271 and then over 3, right? So 2 times 0.271, what is that? That's 0.542, right? All over 3, x squared. I just multiplied 2 times that. It's easier to multiply, right? 2 times 1 is 2, 2 times 7 is 14, 2 times 2 is 4, plus 1, 5. Okay.
How does that have, oh wait, no, never mind.
Yeah, I just multiplied the numerator by 0.271. Or you can multiply the entire 2/3, it's fine, by 0.271. Okay, but we have to get exact values, right? Okay, now we know that if we're going to write this in standard form, we have to express this as p of x equals 0, right? So I can just subtract by 37.5 on both sides. So therefore, your equation in standard form would be 4/3 x cubed plus 0.542 over 3 x squared, and then minus 37.5. So this is going to be your equation in standard form. Once it's in standard form, we can try to graph this, because it's difficult to factor because, again, you have a decimal. So, but again, if it's factorable, then we can use the factoring method. Or we can use, this one we cannot use quadratic formula because it's cubic, right? Okay, so standard form, and then just graph on this. All right, and it's going to give you the value. We know the x-intercept is going to be the solution to the polynomial. Okay, so but then before you can do that, you have to make sure that you know how to simplify. Okay, all right, so if we graph this, it's right here. It's right here. So it's going to give you the x-intercept, and that's going to be this point. Okay, which is 2.99. So if you're going to round it off to nearest tenth, it's going to round up. So we can write this as 3.0, right? Okay. So if you go back, therefore we say, using the graph, x equals 3.0 or 3 feet. And we know this is the width, right? This is the width of the rectangular box.
So do you plug that now into
Yeah, because we're asked to solve for the width. So once we have the x value, we represent that as the width. So that's the answer. We don't have to plug it in back to the equation. Okay? That's the answer. Any question? Okay. Another problem, okay, in the release questions are this kind of problems, but these are also applications to a polynomial, right? If you know how to factor, right? We can use that, right? The area of a rectangle is 4x squared minus 16. Which binomial factor could represent the width of the rectangle? So when you say area of the rectangle, we know the formula for the area is just length times width. So if you know the two factors, then those can be it's either of those two factors that can be the representation of the width of the rectangle, right? Okay, so again, area is length times width, and once we have the two factors, then the width can be either of those, okay? So we know 4x squared minus 16 can be factored, right? We can take out the greatest common factor, which is 4. And then we can divide that by 4. So 4x squared minus 16, that's going to be x squared minus 4.
And you don't turn x squared into just x.
I mean, we can factor x squared so that we can turn it to x, right? How do we factor x squared minus 4? Yeah, difference of 2 squares. So I can write this as x plus 2, x minus 2. So basically, once you express that in this form, length times width form, right? So if you're given one of the factors as the length, then the other one will be your width. But we don't know what's the length, what's the expression for the length, right? So therefore, the width, it can either be x plus 2 or it can either be x minus 2. Okay? Some of these problems have options, so you can look at the options. Right, so it's either x plus 2, that's the representation of the width, or it can either be x minus 2. Okay, but if you're given one of the length, the dimension, one of the dimensions, which is the length, then you can just select the other one as your width. Okay? All right, any question with number 2?
Yes.
Yeah.
How come why do we just factor it? Like,
when we factor, we have to simplify the factors. So if you can factor this, yes, you can factor this as 2x plus 4 and 2x minus 4. But again, you have to factor the 2x minus 4 again. So that's going to be a longer process than this. Okay? All right, but you can do that, but again, you have to factor completely, meaning you have to simplify further. Okay, number 3. Number 3 is, it's like the same as what we had yesterday. We're going to find the value of k, meaning to complete the entire polynomial. But this time we're given the roots, and then you're just going to simplify based on the roots, right? You write this as a factor and then simplify to come up with a standard form, and then find what's the coefficient of x. That's going to be your k, right? Okay, so again, the polynomial is represented as f of x, and we just have to write the roots as factors, right? So we got 4, -3, and 2 as the roots. So I can write this as what? X minus 4, and then x plus 3, and then x minus 2, okay? And we know that all of these factors will just be multiplicity of 1 because the polynomial, the given polynomial is cubic, right? All right, so we just have to simplify this. We can multiply the first 2 or we can multiply the last 2. It's up to you. It's going to give you the same equation anyway, right? So we can, let's say we're going to multiply these, right? So we can do the FOIL method, x times x, x times 3, -4 times x, then -4 times 3. So you can write it's x squared minus 4x, or you say plus 3x. Okay, -4x plus 3x, and then -4 times 3 is -12. And then you can simplify this.
It'll be x squared minus x minus 12.
Yeah, x squared minus x minus 12, and then multiply by x minus 2. Yes, so that you can come up with the cubic polynomial in standard form. So we just have to multiply this binomial by this, right? So we can start multiplying the x to all of the terms in your trinomial. So because x times that is going to be x cubed, right? X times -x is -x squared. And then x times -12 is -12x. And then just multiply the -2 again to the trinomial. Okay, I can just do that here. -2 times x squared is -2x squared. -2 times -x is positive 2x. And -2 times -12 is positive 24. And then just combine like terms so that we can come up with a standard form, right? Okay. Combine like terms. So x cubed is just one term, so we don't have other terms that has x to the power of 3. So just copy. And then we know -x squared, we can combine -x squared, -2x squared, right? Which is -3x squared. And then -12x plus 2x is -10x. And then plus 24. Okay, so that's going to be the polynomial in standard form. So therefore, from the polynomial, what do you think is the value of k? Negative 10. So k is negative 10. So because we know k is in here, in this notation, k is just the coefficient of x. And from here, we know the coefficient of x is negative 10. So k is equal to negative 10. Okay? Any question? Yeah. Now we can read the fourth problem. Anyone? You want me to spin the wheel?
Yeah.
Okay, spin the wheel. Just reading the problem. Okay? Yeah.
Oh wait, why is it plus 2?
Why what?
Oh, never mind. We're good. We're good. We're good. We're good.
Okay. Okay, number 7. All right. Ella?
Mary is purchasing X shirts that cost $15 each before tax. The function h of x equals 15x models the cost to purchase X shirts. The function j of x equals 0.20 times 15x models the discount that will be applied to the cost of X shirts. What is the value of k if the function m of x equals k times x represents the cost of X shirts after the discount but before tax?
Okay. All right, so we have the representation of the functions. H of x equals 15x. That's going to be the cost to purchase X number of shirts, but we don't know how many shirts, right? So we'll just say X, 15 times X. And then J of x, the function J of x is your cost, the discounted amount, right? And from here, we know 0.20 is going to be 20%. So meaning the discount is 20% from the original amount or original cost, which is 15x, okay? And since we are just asked, so this is the kind of question wherein we're just asked to model, right? Write the model of the discounted costs, meaning the cost after the discount, right? Okay, and we know h of x is 15x, okay? This is your costs of the X number of shirts. We don't know how many, but say 15 times X, meaning the price of each shirt is 15, let's say $15, right? Okay, and then J of X is the discounted cost, right? So that's, or the discount, 0.20 times 15X, which is, what is that? What is 0.20 times 15? That's 3, so 3x. Okay, this is your, what is this? Your discount, right? After you multiply 20.20 to the 15x. Okay, since we're just asked to write the function m of x, it's another function, right, which is the discounted cost. So m of x is just, we know we just have to subtract h of x and j of x, right? The cost minus the discount. So h of x minus j of x, okay? And we know the representation of h of x is 15x, and the representation of j of x, the simplified form, is 3x. So minus 3x, and therefore m of x is equal to, what is 15x minus 3x? 12x. And so since we already expressed this one into m of x equals kx, and we're asked to solve for the value or find the value of k, therefore k is 12. Any question? All right, now your classwork again is patterned to this notes, right? Each problem is similar to this problem, okay? All right, so number 5. Okay. Number 5, a function is shown below. 4x cubed minus 5x squared minus 23x plus 6. What is the distance in nearest hundredth of a unit between the two zeros that are closest to each other? Well, yes. And then because this is cubic, therefore we should have 3 zeros. So that means we're going to find the closest two zeros and then find the distance of these closest zeros. Okay? Among the 3.
Don't you put this one on Desmos?
Yes, you can graph this in Desmos, but then what if you're asked to solve algebraically? Let's say it's on the test and you're asked to solve algebraically.
Would you set it equal to 0?
Yes, and then factor, right? Okay. But this is a 4-term polynomial. Okay, this is an example where I presented this because I want to explain that part wherein you were stuck on that last question on the quiz. You think that it's not factor, but when you graph it on Desmos, it shows you the x-intercept. So that means it is factorable, right? Okay, so how do you factor such polynomial like this? We're going to group. Or if it's not possible, like if after you group and it cannot give you the same or common factors, then we try to figure out of trying to split some of the terms so that we can group it in another way. Okay? So let's say we're gonna try to group it like the regular grouping, right? So let's say 4x cubed minus 5x squared plus negative 23x plus 6. You can't, right? Because if we take out the common factor, which is x squared, this is just 4x minus 5, right? And we cannot factor that, right? There's no common factor for negative 23x and 6.
There's no factorable solution.
Well,
Because you can't do 4x and 6, you can't do 5x squared and 6.
yes, so that's why we cannot use that method, the grouping method, okay? But again, we can still do that once we take some parts, right? Or break some of the terms into 2 parts or 2 terms, right? Okay. So how do we do that? Now, it's actually guess and check. If you're used to factoring, then you will be able to figure out that, okay, I can try to explore by trying to break each equations into 2. Each term into 2. So let's say I'm just going to look at this 2, okay? And try to break this term into 2 and this term into 2 so I can have 6, right? Because I'll try to think of how do I break negative 5x squared so that it will have a common factor with the first term. And how will I break negative 23x so it will have a common factor with the 6, right? So we're going to think that way if it's not factorable. And when you graph it, it's still you still have the zeros or the x-intercept on the graph, okay? Only if you cannot find, let's say it's degree 3, and you cannot find an x-intercept on the graph, meaning the solutions are complex or imaginary, right? So that's why you have to use quadratic formula. But then if you try to graph this, it's going to show you the 3 x-intercepts, right? So that means it can be factored, but in a different way, okay? Okay, so let me try to do, negative 5x squared. How can I break negative 5x squared in such a way it will have a common factor with the 4x cubed? I can break it into, let's say negative 5, so I can do negative 4 and negative 1, right? Negative 4x squared and negative x squared. Right, so that I can put the negative 4x squared beside the 4x cubed, right? So that you have a common factor, which is 4.
Are we going to have one like this on our test?
If you're splitting that term up, wouldn't it just be x?
Negative 4 we're just splitting this, Ivy. So negative 4x squared plus negative x squared is actually negative 5, right? Negative 4 plus negative 5, negative 1. And then negative 23x. How do we split this? How do we split this such that there's a common factor with the look at the last number, which is 6, right? So if I can express this as 24, 24 and 6, you can find a common factor, which is 6, right? So I can write this as negative 24x and positive x. Right? Because 24 and 6, there's a common factor, which is 6. So I can write this as 4x cubed, okay, minus 4x squared minus x squared, okay? This negative 4x squared and negative x squared is coming from negative 5x squared. And then I can, again, split the negative 23x into plus x minus 24x, right? Plus 6. Does that make sense? Or does that make sense? Okay. It's like trying to think of something. It's like, you can manipulate the equation as long as it makes sense. Like it should add up to the original form. Okay?
If you give us one of these on the test, will it be calculator active?
Calculator active, yes. So you can check the zeros, but then if you're asked to show all the work, just use the graph to check for the zeros, but you have to show the work. Okay?
So then can we just work it out on Desmos real fast? Like, can you show us how we do it on Desmos?
Yeah, I will after this.
Okay.
Yeah. Okay. And then I can do that for 24 and 6, right? But I can rearrange this. Hold on, because all of them must be factorable by 4, right? Oh, so this one I can factor this as 4x squared. Okay, let's try to do that. So 4x squared, and this one is going to be what? X minus 1. Right? Okay. And then, can we factor this? Now let me just show the part where I'll just break this into 3 groups. Okay, hold on. So it's easier to look at. Okay, because some of you are just like looking at the equation without, 4x cubed minus 4x squared, okay, plus negative x squared plus x plus negative 24x plus 6. Okay, so we have 3 groups, and from there we can try to take out the common factor. So the common factor of the first group is x squared, and I can do, 4x squared. I can do x minus 1. Okay. And then this one, I can take out the negative x, right? And this one would be x minus 1. Right? Okay. That's why I try to break the term into pieces. Okay, 2 terms. How do you factor this?
That would be 6.
Okay, so that would be, I'll just use negative 6 because we have a negative here. So negative 6 and then x minus 1. Oh, sorry. That is, hold on. Oh, no. This is 4x. Yes, 4x. So it doesn't work?
No.
That means
That we did everything.
that means we have to regroup. Okay? So that means the last 2 terms we have to regroup.
There's like no way we're gonna be able to do all this in time.
We can? We can? Now, who can? We have 3 groups because I tried to break these 2 into 2 different terms. So we have 6 terms in total. That's why we have 3 groups. Okay. So who can figure out how to regroup and make sure that the factor will be the same? Because we should have the same factor, right?
Do you not have your notes like filled out?
Yes, I have. But I want you to figure out what. Well, let's say you're stuck because this is the problem that you had on that quiz.
Well, I just wouldn't answer because I'm gonna run out of time.
This is the problem we had on the quiz.
And then you can check using the graph.
Wait, how did I get it right?
Huh?
Did I get it right?
You get it right because I allow or I consider the graph. If you use the graph, then you can look at the multiplicity.
Okay, so if you graph it on just, okay, so that's what, I just like switched around it until I got it right. I switched around until it looked the same.
So who can figure out how to regroup?
Do you know how to do this, Mr. Napoli?
Yeah, I know.
Are you sure? It's really hard.
We give
So
up.
can we just plug it into decimal?
We can, but again, we have to show the work if you're asked to show algebraic work. Okay. All right, look at this. So again, I want you to have this mentality to not give up. Okay? Because that's the skill that we need to learn in math, especially in Math 3 honors. Right? Yes.
We're waiting for you.
Can you see if I did this right?
Yeah.
Asher, do you get this?
So if we,
No, I'm too tired.
We're waiting for Asher to move on to the next question. He'll figure it out.
oh, because you use -2.
I took the factors of the 6 and I guessed and checked until I got a 0.
Okay. So you use so you do guess and check and use -2 and the remainder.
That took me way quicker
Yeah.
than
But okay, yes. And did you check the graph? Can you check?
Right.
Is it right? Okay. So
Your way, not your way. Not her way.
yeah. You can do Cadence way. Okay, Cadence way is she tried to guess and check to use synthetic division and find one that will give you a remainder 0. And then from there you can reduce and then factor. Okay. But let's do this. We will not give up, right? This is Math 3 honors and we do not give up. Yeah. That is right. That is right. Good job. Let's give a round of applause to Brody. Yeah, I tried to do this so that I want you to figure out how to regroup. Okay? So Brody said, you switch the -4x squared, -x squared. So you put 4x cubed minus x squared, and then after that will be -4x squared because you can factor it as that, 4x minus 1. Yeah, it's just rearranging. Ivy, this part.
Okay, wait. Oh, okay. Sorry, I didn't understand what you were trying to do.
So yeah. Let me just write this down here. This is 4x cubed, okay, minus x squared, minus 4x squared, then plus x, minus 24x, plus 6. This one. It's the same thing, but we just changed the order of -4x squared and -x squared. Why? Because we know the last factor is 4x minus 1, right? So we have to have a common factor of 4x minus 1. Okay. I'm just going to do this again, and we'll factor again. Okay. Yes. Can we now find a common factor? Yes or no? Yes. So, the common factor in the 3 groups, right? So we have, if this is x cubed, this is 4x minus 1. If this is -4, yes. -4x, right? Just -x. Just -x, and this is going to be same thing, 4x minus 1. And then take out the -6. And then that's going to be 4x minus 1. Okay. So now, we can just put all these outside factors as 1, right? So I can write this as x squared minus x minus 6, right? And then copy the common factor, which is 4x minus 1. And then we know we can factor negative 6, right? Factor negative 6, think of two numbers multiplies negative 6. The sum is negative 1.
Negative 3 and 2.
Negative 3 and 2. Okay. So I can write this as negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. So you can write this as x minus 3, x plus 2, and then 4x minus 1. So these are all your factors. And from there, you set each factor to 0 and solve for x. Okay, so we got x minus 3. I'm just going to write it on top. X minus 3. X minus 3 equals 0. X plus 2 equals 0. And then 4x minus 1 equals 0. So therefore, x equals 3. X equals negative 2. And this one, what is this? If you add 1, okay, positive 1/4. You add 1, it's going to be 4x equals 1. Divide by 4. Right? So x equals 1/4.
And now the Desmos way?
And now the Desmos way. Well, if you plug it in on Desmos, again, you just have to look at the x-intercepts to check your values, right? So if we plug it in, that's going to give you 3 zeros, right? So same numbers, negative 2, 3, and 0.25, just to check. Okay, so which of these zeros are the closest to each other? 0.25 and 3, right? Because negative 2 and 0.25, which is closer? Negative 2 to 0.25 or 0.25?
2 to 25.
Oh, hold on. What is the difference between these two? 2.25. Okay, 2.25. What is the difference of these two?
2.75.
2.75? Okay, so these two are closest. Okay. All right.
I didn't take very good notes.
So you have what? So these two, negative 2 and 1/4, is the closest two zeros. This and this. So what is the distance? Just have to find the distance to make sure this is always positive, right? So distance of this to this is just 2.25. So distance of the closest two zeros is 2.25 or 2 and 1/4. Okay. Yeah. Again, if you find the distance, you just have to find what is the space between the two numbers, the two integers, right? Okay. So on the number line is 2.25.
Because you're finding absolute.
Question. Okay. Now number 6 is going to be a challenge. Okay. Oh, number 5 is a challenge, but number 6 is more challenge. Okay.
So we're doing it together, right?
Huh?
We're doing it together, right?
Yes, we're going to do it together. Okay, so number 6 is going to read the problem. Any questions, by the way, for number 5? Okay, so let me spin the wheel. You volunteer. You can volunteer if you want.
Now just spin the wheel.
What are we spinning the wheel for?
To read number 6. Number 10. 10, Sam. Is it? Are you Sam? Yeah.
Oh wait, I
Number
am
10.
number 10.
Yeah, you're number 10.
Shoot. Okay. We're going to fence in a rectangular field. If we look at the field from above, because of the
Yeah, look
building
at
size, or
Look at the problem.
$10 per feet. The cost of the bottom is $2 a foot, and the cost of the top is $7 a foot. If we have $700, determine the dimensions of the field that will maximize the enclosed area.
Okay, so this is the concept. So basically, polynomial functions is really applicable with optimization problems. When say optimization or maximization problems, for example, if you're a manager or if you are like a businessman, you want to maximize your profits, right? So you will try to figure out, with these unknowns, you'll try to figure out what would be the values that's going to maximize something or minimize something, right? Okay, so basically that's the concept of polynomial functions. Why we're learning polynomials, because it's prerequisite to calculus. And this part, what we're going to be doing here is a concept in calculus, but we have to learn in Math 3 Honors, because you will be going to, most of you will be going to that route, correct? Okay. All right, so we have to figure out the model, right? And the figure. So we know it's a rectangular field, so we know the shape is a rectangle. And we know vertical sides is $10 per foot. So vertical, so this is 10. And then that's top. The cost of the bottom is 2 feet, and the cost of the top is 7. So this is 7, and this is 2. Okay, and then so vertical side, so both sides going to be 10. Okay, so if let's say we're going to represent, because we don't know how long is your vertical sides of the rectangular field and the horizontal sides, so we'll just represent this as x for the horizontal and then y for the vertical, right? Okay, and the area and the cost is $700, right, for the enclosed area. Okay, so I can write this as what? Or the enclosed space, enclosed area. So this is the area, but then we just have to figure out the perimeter, right? Okay, just add these. Okay, so that's going to be 20y, yes, plus 9x equals 700. But we know the area is length times width, right? Okay. So area is length times width. Okay. So we're gonna express this as because in order to maximize the area, the enclosed area, okay, we have to express this in terms of a variable and in times another variable. Okay? So if this is the case, then I can, let's say I'm just going to express this in terms of y. Right? So how do we do that? That's going to be 20y equals 700 minus 9x, right? I'm going to subtract 9x on both sides. And then divide by 20. So y is represented as 700, I'm just going to write 700 minus 9x over 20.
Why did you divide by 20? Just to get the y alone?
Yes, so just to isolate the y. Yes. Okay. And so if that's our y, and we know the y is, let's say that's the width, right? Because that's the shorter side, the vertical side.
Just plug. So just put 10 times 700 minus 9x over 20.
This one, we can plug it in. So if you say that's our width, this is our width, we can plug it in here, right? Yes. So that's going to be what? We represent this side as x. So x times that. Okay? We represent this as your width. And let's say the length here is also represented as x. So x times this. And so the area will just be the product of that, right? So area equals 700 x squared. Oh no, sorry, 700x minus 9x squared, and then all over 20.
20x? No, 20.
Just 20. Just 20. Okay?
Because you multiply the x.
Yeah, distribute the x. I can also, okay, let's just say, I'm just going to write this as 700 over 20x, right? If you want to do that, minus 9 over 20 x squared, right? That's just the same. Okay? All right. Any questions so far?
Yeah, I'm confused. What are you solving for?
We're trying to solve for the length and the width, right? The dimensions to maximize the enclosed area. Okay? So we're going to take the derivative of the polynomial. Okay, derivative is a concept in calculus, right? But you're going to explore this more in the calculus lesson or in the calculus course. But I have the definition of the derivative on the board. I cannot write the entire definition here. But, okay, so it says the derivative of a polynomial is found by applying the power rule to each term where the exponent of the variable is brought down as the coefficient and the exponent is decreased by 1. So we can use the derivative to find the dimensions to maximize the enclosed area. Okay? All right. So we denote derivative as prime, right? So if this is a of x, right? If this is our polynomial, let's say this is going to be our a of x, then the derivative is represented by a prime of x. Okay? So if we're given a polynomial, okay, I'm just going to write the notation there. So let's say, just for you to have an idea, right? Because you will be using this in the calculus course, okay? So let's say we have p of x equals x to the power of n, okay? Using the power rule of derivative, I can write this as p prime of x equals, I'm going to multiply the exponent. So the exponent is brought down as a coefficient, and then the given exponent is decreased by 1. Okay, so I can write this as n x raised to n minus 1. Okay, that's the power rule of the derivative of a polynomial. So for example, let's say we have this. I have an example there. So let's say p of x equals x cubed plus 2x squared plus x plus 1. How do you find the derivative of this polynomial? So again, the exponent, using the power rule, listen up, the exponent will go as a coefficient, right? So 3 times 1, because the coefficient of the x here is 1, so that's going to be 3x to the power of 3 minus 1, so 3x squared. Okay, changing x cubed to the derivative of that polynomial is going to be, the exponent goes to the coefficient. So you're going to multiply that to the coefficient. 3 times 1 is 3. And then the exponent of the original will be subtracted by 1. Right? So whatever is the exponent minus 1. And then the original exponent goes to your coefficient. So that's 3x squared. How do you express 2x squared as its derivative? So that's going to be 2 times 2, which is 4. And then x squared, that's going to be x squared minus 1, so just x. Right? 2 minus 1. And then what is the derivative of x? If this is 1, exponent 1, 1 times 1 is 1. X to the power of 1 minus 1 is x to the 0. So this is just constant 1.
Wait, why are we learning this now? Isn't this calculus?
We're learning this now because we want to apply that here.
This is not going to be a test, right?
Huh?
Where's the other one go?
This is 0.
Yeah, why did we?
Derivative of constant is 0.
Is this gonna be on the test?
No.
I'll just give this a bonus question, yes.
Bonus question? I'm not getting the bonus, right?
Wait, I'm
Yeah, I'm not getting the bonus.
Are we finished with the?
Yeah, we're not yet done. Okay, I just showed an example how to, listen up. It's just an example. Okay, so how do we do this? This is going to be what? What is 700 over 20x? Derivative of that. That's going to be 700 over 20. So that's going to be a constant. And then here, you multiply this 2 to this. So that's going to be 18 over 20 x.
Is that it?
Yes, and then we're going to solve, okay? We're going to solve because we're going to find the length and the width. So I can write this as 700 over 20 minus 18 over 20 x equals 0. And so we can solve for x, meaning that is our, in that case, that's the horizontal length, right?
Yeah, where'd you get the 18?
I took the 18 from, because I showed an example here. You just have to multiply the exponent to the given coefficient. So 2 times 9 over 20 is going to be 18 over 20. Right? And then the exponent, the original exponent, will be reduced by 1. So it's just x to the power of 1. Okay? And then once we have this, we just have to set it to 0 and solve for x. Right? Okay. So this is just negative 18 over 20 x equals negative 700 over 20.
Subtraction and then divide.
Yeah.
Wait, where did you get? Oh wait, hold on. Never mind.
Yeah. Okay. And then let me just finish the problem. Yeah. So negative 18x, I can just cancel out the 20 because you have the same denominators on both sides, equals negative 700. So divide by negative 18 on both sides. So x equals what? What is negative 700 divided by negative 18?
38.8.
38. Let's just use 38.9. So 38.9 feet, that's going to be your length. And then we just have to plug in this to the equation to solve for y. Okay, we can just go back to the original equation, okay, which is this. The original equation is 9x plus 20y equals 700. And from there, just plug in this x here to solve for y. So 9 times 38.9 plus 20y equals 700. That's 20. And then just solve. This is going to be, yeah. I can use the fraction form of that, or we can use the decimal form. What is 9 times 38.9? Okay, put that on the thing.
Dang, I
9 times this.
350.1.
Okay, let's just use, yeah, 350.1 plus 20y equals 700. And then solving for y, we subtract, okay. There were students last semester who got the bonus question correct, so that's a challenge.
What student last semester?
Spring semester, last year. So 20y equals what? 340.9.
349.
349. Okay. And then divide by 20.
17.495.
So let's just use 17.5. Yes. And this is going to be your width.
So both of those are the answers.
Yeah. Because we're asked to find the dimensions that it's going to maximize the enclosed area.
May I use the restroom?